Continuing our discussion about probability, we talked in the last lesson about permutations. Now we're going to talk about combinations. Remember, permutations, the order did matter, and a combination is a grouping of items in which the order does not matter. There are generally fewer ways to select items when order does not matter. For example, there's 6 ways to order 3 items. The permutations would look like this, because each way we list these 3 items is unique in a permutation, because the order does matter. It makes them unique. In combinations, if I have 3 items, then if the order doesn't matter, then ABC is the same as ACB is the same as BAC, because the order doesn't matter. So I have those 3 items that I'm listing in a combination. So to find the number of combinations, we're going to work a little bit with our formula for permutations. So remember, in permutations, we took the ways to arrange all the items divided by the ways to arrange the items that weren't selected. In combinations, we're going to take that permutations formula and we're going to also involve ways to arrange the selected items. So here's the formula for combinations. N and R is still there. Instead of a capital P, it's a capital C now for combinations instead of permutations. So if we want the number of combinations of 7 items taken 3 at a time, now it's the total number of combinations that we can get divided by the total group that we're after. So N and R still play a role here. So when deciding whether to use permutations or combinations, the question you have to ask yourself is, does order matter? We're going to use a permutation if order does matter and a combination if order doesn't matter. So there are 12 different colored cubes in a bag. How many ways can Randall draw a set of 4 cubes from the bag? Does order matter when he's drawing them? No, it doesn't. So this is a combination. So we're going to use the formula for combinations, and N is 12 and R is 4. We will list these out, but again, we're just going to cancel top and bottom, what's going to be common, and so it's not going to be that terribly difficult to actually get the number. So there are 495 ways to draw 4 cubes from 12. The swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? Is this a permutation or is this a combination? Does it matter how the 2 swimmers are selected? No, it doesn't. So this is a combination. So again, we're just going to fill out N and R in our formula, and we're going to find that there are 28 ways that the swimmers can be selected. So a common form, I know you can't see all this, but I'll read it. A common form of poker involves hands or sets of 5 cards each, dealt from a deck consisting of 52 cards. How many different 5-card hands are possible? So this is a combination. Again, repetitions are not allowed, and so order is not important. Okay, I paused to fix it so you can actually see the question now. So how many different 5-card hands are possible? We know this is a combination because order is not important. So there are 52 cards, so N is 52, and we want 5-card sets, so R is 5. So we'll plug that into our formula and we'll clean things up. We'll cancel top and bottom. What is common? 52 factorial contains 47 factorial, so we're going to cancel that out, and there are 2,598,960 different 5-card hands possible out of a deck of 52 cards. So alright, so find the number of different subsets of size 3 in the set given here with these letters. So that is a combination. And so N is 9. There are 9 letters. 3, the subsets, is 3. So we plug that in, and there are 84 different subsets for a combination. Now we'll ask the same question as a permutation. Find the number of arrangements of size 3 in the set. So the subsets of size 3, where order doesn't matter, are different than the number of arrangements of size 3. That is a permutation. N is still 9, R is still 3, but the formula is different because we don't divide by R factorial. So you can see here where there are only 84 different subsets because order doesn't matter, there are 504 arrangements for permutations when order does matter, because MAT is different than ATM in a permutation, but it's not in a combination. So make sure you know those different formulas, the formula from last lesson for permutations and the formula from this lesson for combinations. And you can see that this factor right here is the only difference. So here are guidelines, mainly the clue words at the bottom are what I want you to see. We know in permutations, order matters, order is important. In combinations, orders are not important, it doesn't matter. We know the formulas, I've already given you those, but these clue words can help you determine whether you're after a permutation or whether you're after a combination. If you see things like arrangement, schedule, order, that's a permutation. If you want a group, a sample, or a selection, that points you towards combination. So that's it. Come to class next time and we'll practice some homework problems on permutations and combinations.